All right, so let's now take a look at the logical laws for conjunction and disjunction. It's a very famous law called DeMorgan. So you actually see DeMorgan in different contexts. For example, you might see DeMorgan's law in the context of set theory. But for now, we'll just talk about logical conjunction and disjunction. All right, let's start with the conjunction. And the way we define disjunction will be very symmetric. Let's start with the slides, and then I'll show you a detailed demonstration. And then we'll go over some example. Okay, let's say now we got any arbitrary Boolean expressions, B1 and B2. You can think about B1 and B2, they might be just Boolean literals, or maybe they're simply like a relational expressions, or they might just be another, for example, B1 just be another expression using logical operator. But just think about B1 and B2, they're simply just true and false, Boolean expression, B1 and B2. Okay, so now, what does this really mean? All right, literally, all right? Let's now try. You can see there is parenthesis over here. So that means we got to evaluate the conjunction over here and then the negation, right? First of all, let's agree on that. So now the way to interpret this in English informally is, it is not the case that B1 and B2 are both true. Agree? All right. It's exactly that. Okay, we're saying that it is not the case that B1 and B2 are both true. But what does that mean? If you say it is not the case, but what would be the case then, right? Hold that thought. And what about another expression over here? How do you say this in English? We're saying that it is not the case that B1 is true, or it is not the case that B2 is true. Basically, you're saying that either B1 is not the case or B2 is not the case. All right, that's basically what it is said. And now, aren't these two expressions equivalents, right? Let's see why, intuitively, and then we're gonna show you how you can prove it using truth table. When we said this is simply said it is not the case that B1 and B2 are both true, meaning that one of them may be false. So either B1 is false or B2 is false, or maybe both of them are simply false, right? You can remember the or. It's like an either or both. All right, intuitively, that's what it means. Hopefully that you get the intuition, hopefully. And now let's now see how we can prove it very quickly by using truth table. You will see the truth table like what we did last time. Since we got two operands over here, B1 and B2, how many rows should we have? We need to get 4 rows. False, 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 true, true, false, and true, true, right? And now, so for now, please only focus on the blue table over here. So now we talk about DeMorgan for conjunction, okay? I want you to really try to read this table in a systematic way, because if you simply want to memorize it, you're wasting your time, right? You're definitely going to forget at some point of your very soon, all right? So now this is how I will understand it for the truth table. Remember, let's start with something we know already from last week. We know that the only way to get B1 and B2, this particular conjunction, to be true is when B1 is true and also B2 is true, right? Let's now go to that row over there. So when B1 is true and when B2 is true, this part here will guarantee this part over here is going to be true. But since we also get some negation over here, so that means this will be the only way. This will be the only way that we can get this part over here to be false. This is the only way. What about the rest of the rows? In the rest of the rows, you can see we will get at least false. Either or both of the operand is going to be false, meaning that evaluating this part over here is going to give you false, and then negating it will give you true. So that means all the rest will just be negating the false, which will be true. Okay, if you if you're finding that my explanation maybe a little bit too fast, please just rerun it. I'm pretty sure I said it very precisely. All right, let's now try the right hand side and see how we can understand it. For the right hand side, again, let's now talk about disjunction over here. We said that over here, let's talk about over here, this and this, right? We said the only way to really make disjunction false is when both operands are actually false, right? So when both operands are actually false, since we got negation over here, so that means B1 and B2 must be true in order to make sure this operand is false and also this operand is false. So that means we're still going back to this particular row over here, right? If we go to this particular row, so that means that's the only way when B1 and B2 are actually true, the only way to make sure negating true will get false and false. That's the only way to make the overall disjunction to be false. All right, so that's the only way that we got false over here. What about the rest of the rows? For the rest of the rows, you can see at least one of them, either or both of the operands are actually false, meaning that either one of them is going to be negated. So false negated will be true. So either operand is going to be false and negated, that will be true. And once we get true as one of the operands for negation, for disjunction, sorry. So once we get one of the operands being true after the negation, so that means the disjunction is going to be true, right? Either we negate this one here, or we negate this one over here, or we negate both, and it's going to be true. As long as one operand for the disjunction is going to be true, overall it's going to be true. So that means we got true over here. All right, that's how I prove it, both by truth table and also describe to you. So I think I really try to pay attention to the way I try to explain and the table systematically to you. It's really important to get an insight, right? That will also help you understand more about the definition for conjunction and disjunction. All right, so that's the DeMorgan for conjunction. Let's now talk about the other symmetric half, about disjunction. I'll get back to the truth table in just one moment. Let's go back to the slides. That's exactly the truth table I just talked about, right? Let's now go to disjunction, DeMorgan. Again, let's assume B1 and B2 are simply just Boolean conditions. And now let's consider one by one, okay? What does this mean? Okay, so this means it is not the case that B1 or B2 is actually true, right? So that means it is not the case that B1 is true. Thinking this way, let me put it simpler for you. Only consider this. So what does this mean? This means B1 is true, or B2 is true, or both are true. However, none of those three possibilities is the case, because we got negation over here. All right, informally. Okay, you can read it. What about this one over here? This one is saying that B1 is not true, and B2 is not true. All right, this one is easier to see. Okay, both are false. So now, aren't these two highlighted expression over here simply equivalent? Okay, hopefully you can see that intuitively. This is how I would take it. We are saying that it is not the case that either B1 or B2 is true. That means both of them must be false. All right. The only way to really okay, so the only way I'll get that. I'll get to the table and then we'll see. Okay, that's intuitively what it means. And then we still got our truth table to explain. Let's now switch to the iPad. Okay. Let's now see this truth table over here. I'm going to explain it in a way very similar to how I tackle the conjunction. Let's do it together, okay, quickly. Let's now start with this expression over here. And let's look at this one here, okay? Remember intuitively, how do we remember the definition for disjunction? I said the only way to make the disjunction false is by having B1 and B2 both being false. That's the only way. So now let's now go to that particular row. False and also false over here. So now when we have this, so that means this part over here is going to be false. That's the only way. And then since we got negation, that's going to be true. So that means as far as this operation is concerned, the only way to make it true after negation is this row over here. That's the only way to make it true. Over here. What about the rest of the rows? So now for the rest of the rows, you can think in this way. For the rest of the rows, either or both of the operand is going to be true, right? So that means either one of them is going to be true, either this one here or this one is true. So that means the disjunction here would be true, and then negated the true, it would just be false. So that means all the rest would just be false. Okay, hopefully you are fine so far, right? You can see programming is not just about coding. Programming is about understanding logic as well and apply logic to the code. But we are still learning together. All right, what about the right-hand side over here? So now I'm saying basically not B1 and also not B2, right? And thinking this way, okay? You can see ampersand is a conjunction. The only way to really make conjunction true is when this is true and this is true, right? That's the only way. However, right now, both operands actually contain negation over here. So that means in order to make this true, B1 must be false. In order to make this negation true, B2 must be false, right? So now B1 false and B2 false. In that case, we are still talking about this row over here. So false and false is the only way to make sure negated false and also negated false. Overall, it's going to be making the conjunction true. All right, so that's the only way to make this true. So now you can see so far they correspond to each other, right? What about the rest of the rows? For the rest of the rows, you can see that since this is a negation over here, so negation of true will be false, right? So now you can see over here, either for the rest of the rows, either or both of the operands is going to be true. That means either B1 or B2 over here will be negated. One or both of them will be negated. Let's say if any one of them is negated, for example, this one here, if that one is somehow not true, for example, right? Let's say this guy here, I'm talking about over here. If not true, that's going to be false. As long as I got false already, so that means it's not the case that both are actually true. So that means the result for the conjunction will guarantee to be false. So that means for the rest, it will simply just be false over here, right? So guys, I think there are two levels, there are two dimensions of understanding you need to have. Let me recap, and then we should see some practical example to really see how we can apply DeMorgan into coding. So one is you have to, if you go back to the slides, you will see the intuitive explanation I try to give to you to see why. For the DeMorgan for conjunction is to say this is equivalent to this, right? And the DeMorgan for disjunction is to say this is equivalent to this. You can see the slides for the intuitive explanation. The second dimension you want to understand is when we try to use the truth table to prove it, and the way I try to reveal the rows and columns one by one in the gradual level. So I really try to give you the insight and also recap about the definition for both operators. So these are the two dimensions you want to understand properly. All right. So now I don't need to go back to the slides. You will see the next few slides. The next two slides are just about examples of DeMorgan. So let me just go over them one by one together with you.